We're going to talk today about solving quadratic equations by using square roots. This is a very specialized method. Remember that all positive real numbers have two square roots, a positive root and a negative root. So for instance, the square root of 36 is plus or minus 6. That's how we say that. To check to see if that's true, we can just simply say, okay, 6 squared is equal to 36. And negative 6 in parentheses squared is also equal to 36. Okay? Standard form of a quadratic function is y equals ax squared plus bx plus c. All right? If we were to remove the b term, if you have something that is in this format, then you can solve by taking square roots, but that you cannot have that x term in the middle there. So, for instance, here's some examples very quickly. If you have x squared is equal to 169, then to solve this, you would simply take the square root of both sides. The square root of x squared is x, and the square root of 169 is plus or minus 13. Okay? If we were to take this one and take the square root of x squared is x, and here we are trying to take the square root of a negative 49, which means that is impossible. That is no solution, no root, cannot be done. You can only take square roots of positive numbers, never a negative number. Okay? We try this one. Take the square root of both sides. We get x is equal to 0. In this case, we only have one root, one solution, okay? One answer there. All right? Let's try a couple of these. Now, these are set up just a little bit differently. What you've got to do is isolate the x squared first. So I'm going to start this one by adding 49 to both sides. That's going to give me 16x squared is equal to 49. Then we're going to divide both sides by 16. That's going to give me x squared is equal to 49/16. And then lastly, we're going to take the square root of both sides. That's going to give me x is equal to plus and minus 7/4. So positive 7/4 and negative 7/4. You might want to pause the video and try this next one. All right, you see that you have a binomial squared here. Well, let's just get rid of this square. So we are going to take the square root of both sides first. So the square root and the square cancel out, and we're left with x minus 5. So this is a little bit different. Is equal to the square root of 16 is plus or minus 4. Now we need to add 5 to both sides. So we've got x is equal to 5 plus or minus 4. I should have two answers here. So 5 plus 4 is 9. 5 minus 4 is 1. There are my two solutions to that. And we should end up with two solutions for the most part for quadratics. Okay? Sometimes when we go to take the square root, it's not a perfect square. So we're trying to take the square root of something that's not a perfect square. In that case, we're just going to approximate it. So here we take the square root of both sides. That gives me x is equal to plus or minus radical 15. We just do that on our calculator. This is called an irrational number. So when you're trying to take the square root of something that is not a perfect square, it's irrational. So try this one. Okay, we're going to isolate this first. So I'm going to subtract 90 from both sides. It's going to give me negative 3x squared is equal to negative 90. Divide both sides by negative 3, and you get x squared is equal to 30. 30 is not a perfect square. So when I do this, I get x squared is equal to plus or minus radical 30. And the square root of 30 is plus or minus 5.48. And that's it.